Welcome to module 23 of programming in C++. We are discussing about inheritance in C++. We have talked about the basic requirement of inheritance, and we have touched upon, we have discussed the very core two concepts of the effects of inheritance between two classes. That is, how does the data members are inherited and object layout done, and how does the member functions can be inherited with overriding and overloading playing a role. In the current module, we will try to talk about the protected access specifiers, the semantics of the access specifier, and what happens to the construction destruction process, and relate that to the issue of object lifetime in the context of specialization scenarios. The outline, as I have already explained, is for the whole of this inheritance, and the blue part relates to what we will be discussing in this current module. This is for your quick reference, that these are the broad semantic requirements, and these two we have already done, and this is the one that we will be covering in now. Now, so what is the access specification issue? The access specification issue is, as we know, there are two kinds of access specifiers, the private and the public. So, for any class we have private members, data as well as functions, member functions, and we have public. So, this means the private members are available only to the class, and the public members are available to all other classes, global functions, and so on. So, with that, if we have done a specialization, then the derived class certainly cannot access the private members of the base class, because the derived class is by definition another class. So, it is outside of the base class. So, it cannot access the private members. So, it can access only the public members. Now, as we will find that the whole advantage that we want to take by modeling inheritance, by modeling the generalization specialization hierarchy, by introducing the features of overriding member functions and so on, will be lost if the derived class cannot access any part of the base class, which the base class protects from everyone else. So, that has given rise to defining a new kind of access specifier known as protected. So, the protected has a special semantics that a derived class can access the protected members of the base class, but no other global function, no other class, or global function can access the protected members. So, what it means that if I look at a protected member of a base class, then for the derived class it is like a public access, and for other classes and global functions it is like a private access. So, we are kind of trying to, the attempt has been to create a third kind of visibility or access specification beyond private and public. So, that private is totally inside the class, public is totally for everybody, and protected is something that is for the class, but for some of the classes with whom this class has a very close relationship of specialization, generalization, or parent child kind of. So, let us look into example. Again, please look at the left side, do not look at the right. So, we have a class B which has a private data member and a public method. The public method simply prints the data member. We have a derived class D of B, which again has its own private data, which is the additional data, and it has a public method print. So, having understood the inheritance of member functions, you will realize that this is a case of overriding member function that is occurring here, because both these print functions have the same signature. So, D as it is inherits this, but then it overrides and declares it again and possibly gives it a different semantics. Whatever is the body here and the body here are different, and this is what we have. And then what we want to do is to instantiate these objects and invoke print from both these objects. That is the basic target. Now, let us look into the access issues. This is, that is, the data, the member data of class B is private. Therefore, it is inaccessible to all, including the child class, including the derived class. It is not accessible. So, if I want to write a print function in class D, which prints the whole of class D, how will the class D look like? Class D will look like, and layout of this is, we have already discussed this. There is a base part which has this data 1, there is a derived part which is info, and that is the class. So, if I want to print this class, then I actually have an int b colon colon data member in this class, which is this member. So, to be able to print this, I must print this as well as the info, which is the member of this class. The question is that how do I access this data? This data is a private member of this class B. So, if I may make it explicit, when I talk about this data, I am actually, if I fully qualify applying the namespace rules, then I am actually talking about this element B colon colon data, which has been inherited by the inheritance rule of specialization. So, accessing this data is basically accessing this data, which by rule is not accessible to anyone else. Therefore, this print function cannot compile, it cannot work. Certainly, if outside, if I just write b dot data, it will not compile, it is not accessible, it is not accessible for the outsiders. So, this will so this is the core problem that the protected access specifier is trying to address. Now, if D cannot access this, then there is no fun of having this data member inherited in this part of this class. So, that will mean that every time I inherit, the base class will have an instance as a part of this object, but that cannot be read or written by the derived class. So, it is kind of dead part in the object layout. Now, for that, if we make this public, if we move this here, then naturally this problem will get solved. Print will be able to compile this, but then it breaks the encapsulation, because anyone else will also be able to come and read and change the data. So, we need to provide a specification which is in between these two extremes, and that is where we now introduce the protected specifier. Earlier this was private, now this is protected. So, in data is protected. So, nothing else changes in this code. So, when now in the print member function of class D, we try to refer to data, which again is B : data is this member, this access is allowed, because being protected it is accessible to the child. But just look at this. This has not violated the restriction on the other use. This is written somewhere else in some other global function or some other class, but that will not, that access will not work, because wherever I have written this is not a part of a derived class of B. So, had we made this public, then this would have worked, but this would also have become accessible. But making this protected, we have made sure that this will work, but this will continue to be a compilation error. This access will not be allowable for here. So, that is the basic meaning of the protected access specifier. Here I am showing it in terms of data members. The same semantics, exactly the same semantics will work for member functions as well. So, any derived class would be able to therefore access both the public as well as protected members of the base class. So, now with this we will be able to implement, compile and also invoke the both print functions. One for this is simply for the B class member, and this as we have overridden, then this is for the D class, where the base part will first be printed and then the derived class part will also be printed. So, that is the basic notion of private access specifier, and we will often find a good use of this happening. I just in this connection, let me show some more examples. So, here I am just showing the use of further use of the protected members. So, here is a protected member. So, if you look into this class, then you will find that let me put it cleanly. If you look into this class, it has protected data member, which is shielded from outside, but certainly can be used by the derived class, and this class has some friend function which is trying to print that class. Now, interestingly, this being a friend function is as it is not available to class D, because this function, as we know, this actually is a global function. It is just a friend, so that it can have the visibility. So, because this is a friend function, it has the access to the private data members of the class B, but it will also, that access would also be extended to the protected data members of class B, because being a friend, this overloaded operator function has complete access within the inside of the class B. Now, if you, and assuming that you do not have, you have not written say this operator function in class D, and you have instantiated the two objects here. Naturally, B needs one data for this data part, D object needs 2, this will become the data, is the base class 1, and this will become the info. Now, if you try to do this, what will be your expectation? Certainly, your expectation would be that if I do C out B, this is the invocation of this function, that is the C out B is basically operator output stream, first member C out, second member B, first member C out O stream, second member B. So, this should invoke that operator and print the B object, which it does correctly. But the interesting fact is that what happens if you also write this? What is this? This is operator D. This D is of type class D and not of this type. So, you would expect your first reaction would be that this should be a compilation error, but interestingly it is not. It is not a compilation error. This will also go through. What it will do is, and that is very risky, and that is the reason I brought up this example, is the moment you start using protected and start using friend functions, you will have this. What it will do? It will invoke this function itself, but it needs a B, but it has a D. How will it work? Recall the layout. The layout is the D object has two parts. One is the member it has defined, which is info. Other is an instance of the base class object. So, what is happening here? You require a base class object at this point, and you actually have a derived class object at hand. But a derived class object also has the base class part. So, what the system does? System simply ignores the additional part. It simply takes that as if this is the base class object which you wanted to pass, and lets this function be called. That is the reason. Just look at the result very carefully. This gets printed, B object value 0 gets printed from this C out, which is correct, because I created object B with a value of data which is 0, clear enough. This also prints that this is a B object and a value is 1, which is basically, this value 1 is basically the value of the B : data inherited member that we are setting at this point. And the 2 which actually got set to info will certainly not get printed, because this function does not even is aware of the existence of this particular data member. This whole phenomenon happens because of something known as implicit casting, of which we will discuss about much later, but I just wanted to give you this glimpse of this example to sensitize you that in terms of actually overloading friend functions and so on, since friend functions take the object as parameter and are not invoked on the object like other member functions do, you do run the risk of implicit type casting, and you will have to be careful to protect against that. Naturally, the solution, the problem will become all right if you just have the overloaded operator function here as well as another overloaded operator function here, where you can certainly use data, because data is a protected member in B. So, D can inherit as well as access this data, and in that context for these objects, if you try to do C out, this will go here, this will go here, and now this is happening not by overriding, this is happening because of the simple overloading, because friend functions are global functions, they are not member functions, there is no context of overriding here. It is just these two functions defined in two different scopes are being resolved by the difference in their signature, and both of them will correctly now you will have a D object which prints 1 and 2 both. So, that is a basic kind of behavior that you will expect when you start exposing the inner of the object in terms of the protected data members or protected member functions, so to say. Let us move on and quickly talk on the constructor destructor. Now, when the derived class inherits the constructor and destructor of the base class, but you have to be very cautious. It is with a different semantic. See, if I say it inherits, then the problem is a constructor is a fixed name function. A constructor of a class has the same name as the class. So, if I inherit the base class constructor into the derived class, then certainly it cannot behave as a constructor. So, the base class constructor becomes kind of a member function in the derived class constructor in the derived class. Similarly, a base class destructor becomes kind of a member function in the derived class, and there, but it is very important that this inheritance of the constructors are possible, because again recall that any derived class object has a base class instance. This is a instance of the base. So, if I have to construct the derived class object as a whole, certainly I will have to construct the base class instance part of it, and that needs the base class constructor to be available. Similarly, if I have constructed, then I will need to destruct. So, by symmetry I will require the other. So, this quickly shows what is possible. You have a base class constructor here, which the data pattern I have not changed. The base class constructor, there is a base class destructor. This destructor does not do anything, simply prints a message, and the base class constructor is overloaded. It is a parameterized constructor and also a default constructor. So, basically there are two constructors here. For the derived class, we have added one data member. So, there are two values to set. So, what we do, we actually have provided two different constructors, one that takes 2 parameters and the other that takes 1 parameter. Now, what is interesting and new in this whole scenario is this piece of the code in the initialization list. The derived class object that needs to get constructed will need to have a base part instance of the base object. So, this needs to get constructed. Now, the basic principle is that you cannot proceed with the construction of the derived class components. There could be several components here until you have finished with the construction of the base instance, because base instance in a derived class object is unique. It may have 0 or 1 or any number of data members, but if in the under inheritance you can have only one base class instance in the object. So, that must get constructed. So, here what the base class constructor the derived class constructor is doing, the derived class constructor is actually calling the base class constructor. This is the name. So, this function is inherited here, and the derived class constructor is actually calling this function by name, passing the parameter that it needs, which it wants set in the data. So, that first this will happen, this B data will happen and this will get set, and then the other initializations of its own members will happen. What happens in this case? In this case, there is no base class constructor being called. That does not mean that the base class constructor will not need to be called. I have not put it explicitly here, but still at this point the base class constructor will get called, because unless the base class part of the object has been constructed, the derived class object cannot get constructed. So, this will, like the compiler provides the free functions, constructor, destructor, all of that. Similarly, this is where the compiler provides a free invocation of the base class constructor. Now, naturally, if the compiler provides a free invocation, then the compiler cannot set a parameter to the base class constructor. So, this is possible, that is, this kind of a constructor for derived class can be written provided the base class has a default constructor which does not need a parameter. So, very simply, if I just erase this default parameter in the base class constructor, then this will become a compilation error, because it will say that for this overloaded constructor of D, there is no default base class constructor, there is no base class constructor called. So, with this we can construct the objects. For example, if we construct is the D1 object with 1, 2, then certainly this constructor is getting used, 1 gets set to D, then a base class construction happens that gets set to here. So, if we do this, then the eventual result will be that we will have 1 here and 2 here for the object D1. In case of object D2, we are just passing one parameter. So, by overloading, this means that this constructor will get invoked, which means that the base class constructor will get invoked with the default as a default constructor with the default value. So, this will become 0. So, in this case, this part will become 0 and 3 will go to I, which will come here, which will go set here. So, that is how the object will get constructed. So, here I have shown this layout. So, you could take different examples and try your layout and get convinced that how these constructors work between themselves. And similarly, the base class will need to have destructor, the derived class will need to have destructors. Now, with that, if we just try to trace these messages that we have put, and in the next slide we will try to do that. Let us say we will trace these messages. If we just trace these messages and see, then we will be able to find out what is the lifetime of the objects now. So, let us just try to do this, the same construction. So, naturally, when this is encountered, what has to happen? The base class constructor will have to get called for object B. That is the first thing that happens. This message gets printed. Then this construction has to happen. The object D1 of class D has to, if this has to happen, then this constructor gets called, which in turn means that this constructor gets called. So, the next one you see is the construction of a B object with the value 1. This is what here for the D1 object that I am constructing. Once that has been done, then the construction of the D1 object by the constructor of class D will get completed. So, I will get the next message. So, these two is basically the construction of D1. Next is, so we have seen up to this point. Next is the construction of object D2, which invokes this constructor, which invokes the default constructor. So, I will again have a constructor of B called for object D2, but the parameter value is 0. Once that has been done, then the rest of the construction of this will continue and that will print the next message. So, you can see that the lifetime of an object continues to be same, only with the exception that the lifetime of a base object will start before the lifetime of the derived object can actually start. So, that will have to get constructed totally in full. So, which means by symmetry of object lifetime that you have already seen, certainly if we look into the remaining part of the messages as to what happens at the time of destruction, that is when these objects go out of scope at this point. Certainly, this was the last object constructed. So, that will be the first object to get destructed. And what will happen? This was the last construction message. So, if you now look at the first destruction message is for the object D2, that is this message. So, this destruction message is basically this one, this message, and only when the control reaches at this point. So, you first clean up whatever additional members the derived class object has, and only when you have reached the end, having done this, then the destructor of the base class gets called. Then you clean up the base class. So, you are first constructing the base class instance, then constructing the remaining data members of the derived class. On the wrap up time, first clean up the non base data members of the derived class object, and then clean up the base class part. So, if you look into try to trace for D1, you will see the same symmetric behavior, and I would leave it to you to complete. So, this gives you the clear picture in terms of how the layout of the objects will be managed. So, to summarize on this module, we have understood and really analyzed the need and use of protected access specifiers for specifying access to different base class members, and we have seen how the construction and destruction process happens between a derived class object and a base class object, and really tried to trace the lifetime of the derived class object with respect to the base class object.